of exponential numbers. Let's look at three different parts of division of exponential numbers. In number 1, we'll look at a to the power of m divided by a to the power of n, where m is greater than n. In number 2, we will look at a to the power of m divided by a to the power of n, where m is less than n. And in part 3, we will look at a to the power of m divided by a to the power of n, where m is equal to n. And a is any number but not 0. M and n are positive integers. Now let's begin with part number 1. A to the power of m divided by a to the power of n, where m is greater than n. Now we have 3 to the power of 5 divided by 3 to the power of 3. And if we expand this, we'll come up with 3 times 3 times 3 times 3 times 3 out of 3 times 3. And in this case, you can see that 3 is appearing 5 times, and below we have 3 appearing 3 times. Now, if we reduce two 3's, the upper one and the down one, and we do the same, and we do the same again, we will find that we remain with only 3 times 3, and this gives us 3 squared. If we try another method, we can see that 3 to the power of 5 divided by 3 to the power of 3, we can write it in a different way using a division sign. Now, since the bases are the same, we can simply subtract the exponents, that is 5 minus 3, and this still gives us 3 squared. 3 squared. Now, still in part 1, if we have a to the power of 4 divided by a squared, and we expand it, we will get a 4 times divided by a 2 times. Now, if we take away the 2 a's up and down, we remain with a times a, and this is a squared. If we try a different method by getting a to the power of 4 divided by a squared, you can see that we will subtract the exponents since the bases are the same, and still we get a squared. Let's move on to part 2, where m is equal to n, and we have 3 to the power of 5 divided by 3 to the power of 5. If we expand it, we will come up with 1. And if we try the different method, since the bases are the same and we simply subtract the exponents, we will get 3 to the power of 0, and 3 to the power of 0 gives us 1. Let's move on still with part 2. Still we get a to the power of 4 divided by a to the power of 4. When we expand it, we will still get 1. Now, if we use a different method, we get a to the power of 4 minus 4. Since the bases are the same, we will still get a to the power of 0, and this is the same as 1. Remember that any number to the power of 0 is equal to 1. In number 3, we have m is less than n. Now let's have 3 cubed divided by 3 to the power of 5. When we expand them, we get 3 times 3 times 3. Out of 3 times 3 times 3 times 3 and times 3. Now, we will come up with 1 out of 3 times 3, and this is the same as 1 out of 3 squared, and this is the same as 3 to the power of negative 2. Now, in the similar way, if we get 3 to the power of 3 minus 5, since the bases are the same, so we will come up with 3 to the power of negative 2. Now, let's have a cubed divided by a to the power of 5, and then we will still come up with 1 out of a times a to get 1 out of a squared, and that is a to the power of negative 2. Now, if we subtract the exponents, since the bases are the same, still we will get a to the power of negative 2. And this takes us to law 2 of exponents, where a to the power of m divided by a to the power of n equals a to the power of m minus n, where a is not equal to 0, m and n are positive integers. Let us simplify the following. We'll leave the answer in exponential form. In number 1, let's get 11 to the power of 9 divided by 11 to the power of 7. Now, since the bases are the same, we will simply subtract the exponents. That is 11 to the power of 9 minus 7, and that is 11 squared. In number 2, let's have 7 to the power of 5 divided by 7 to the power of negative 3. And since the bases are the same, we will still subtract the exponents. That is 5 minus negative 3. This will give us 7 to the power of 5 plus 3, and that is 7 to the power of 8. In number 3, we have 6a to the power of 17 b to the power of 8 divided by 2a to the power of 4 b to the power of 6. Now, 6 divided by 2 gives us 3. And now we get a to the power of 17 minus 4, b to the power of 8 minus 6. And this gives us 3a to the power of 13 b squared. Part 4. We have x to the power of 10 y to the power of negative 2 divided by x cubed y cubed. So since the bases are the same, we will simply get x to the power of 10 minus 3 y to the power of negative 2 minus 3. So we get x to the power of 7 y to the power of negative 5. And finally, for part 5, we have 3 cubed divided by 3 to the power of 5 times 3 to the power of negative 2. Now, let's first deal with the multiplication. Since the bases are the same, we will simply add the exponents. Therefore, we will get 3 cubed divided by 3 to the power of 5 minus 2. And this gives us 3 cubed divided by 3 cubed. So we get 3 to the power of 3 minus 3 and this is equal to 3 to the power of 0, which is equal to 1.